Hello, everyone, and welcome to our webinar. We're going to begin in just a few minutes, so please hang tight. All right, so it looks like we have a bunch of people joining us already, so I think we're going to go ahead and get started. First of all, welcome to Modern Machine Shop and Machine Metrics' webinar, 2021 Buyer's Guide, Machine Monitoring for Manufacturers. My name is Laura Donovan, and I am the Marketing Communications Manager at Machine Metrics, and I have the privilege of hosting this webinar. But before we get started, I would like to go over a few housekeeping items with you. Yes, this webinar will be recorded. All registrants will receive a copy of the recording after the event. The recording will also be available for on-demand viewing on our website. And most importantly, this is an interactive webinar. Please ask questions throughout the presentation. You can submit them in the Q&A chat to the right of your screen. We will do our best to answer them live. If we don't have time to answer them during the event, one of our industry experts will reach out with your answer following the presentation. We also have a few audience questions corresponding to this presentation. You might recognize them from the registration form. If you didn't answer them when you registered, please take a second to answer them now. They're located under polls, also to the right-hand side of your screen. We're really looking forward to reading your answers. And lastly, we've included some complimentary content downloads with today's live session. If you would like to continue learning about the benefits of machine monitoring, I would highly recommend downloading them and reading them at your convenience. Those will be located right next to the polls under the handout tab. So without further ado, let's dive into it. Graham Imran, a fearless leader over here at Machine Metrics, will be taking you through today's presentation. Graham is the VP of Marketing at Machine Metrics and has quickly become an authority on digital factory transformation and the application of IoT technology for the manufacturing industry. He will be taking us through today's webinar, which will include a brief synopsis of Machine Metrics, an introduction to machine monitoring and its significance, an explanation of how it works, some advice and some expert tips on how to select the best machine monitoring solution for your team, and then how we implement and we help teams with machine monitoring at Machine Metrics. We'll conclude the presentation with a Q&A, so be sure to submit any questions you have in the chat during the presentation. Without further ado, Graham, take us away.
All right, cool. Thank you, Laura. I promised to do a better job of getting through these slides, and I did do those introduction slides. So for those of you who've been with me through a number of Modern Machine Shop webinars, if you're lucky, you'll get a guest appearance from my cat. If you're not, it means that she doesn't like you. But for those of us who are joining us today, welcome. It's great to be here today with you all yet again. As we're winding down 2021, it's been quite a year, 2 years really for all of us. And with a strong resurgence in demand, which we saw about halfway through the year, the US manufacturing activity PMI hit about a new record as recently as July. It was a bright outlook for the remainder of the year. Of course, only to see it fall amid concerns regarding capacity constraints, material shortages, inflation, and supply chain disruption. The simple fact is that the supply chain restructuring has been accelerated by the pandemic, as the effects of this weakened supply chain have become quite visible to everybody, including anyone who's trying to buy a car lately. And many companies are looking to restructure their supply chains, trying to support rise in demand, the balance of resilience, efficiency, and reduced costs. So, is, reshoring, right, the answer? Many companies think so. A recent study from ThomasNet actually showed that 83% of companies queried were likely or even extremely likely to reshore in the coming years, with the top vertical most adept to do so, of course, being our own advanced manufacturing. Of course, with the potential for reshoring comes additional pressure on manufacturers to deliver products in record time while continuing to cut costs, hire skilled labor, and increase the efficiency of your production. And unfortunately, as many of us know firsthand, some of these things are more difficult than others. There are just simply not enough skilled workers to support the sector. And a recent study from Deloitte Insights showed that an estimated 2.1 million open manufacturing positions may prove difficult to fill by 2030. So the reality is that the current workforce is aging out, and really critical tribal knowledge is leaving with them. While a younger digital generation of people are entering the general workforce, they're undeniably leaning towards jobs that leverage software and don't have manufacturing specific skills or experience. So it's, as like I said, many of you already know, very difficult to lure this generation into manufacturing. Not necessarily considered to be the sexy career that we all know that it really is. Thus, the simple fact is it's never been more important to time to reduce the burden of non-essential manual tasks and decision-making. And the reality is that manufacturers can do so, and they can do so quickly. Of course, this has been easier said than done. And while these continuous improvement initiatives in manufacturing really start with capturing insights from your operations, specifically your machine assets and your people, most of these efforts are stifled because this data that's critical to these efforts is not being captured or analyzed to improve efficiency, despite all the innovations and buzzwords that you hear from marketers like myself. The reality is that today's factories are highly inefficient for two specific reasons: a lack of skilled labor, which we just discussed, and monolithic behemoth manufacturing operation software. These stifle digital transformation and manufacturing innovation. Firstly, decisions on the shop floor are over-reliant on people. The older generation of manufacturers are retiring, like we just said, and we're not able to get those people. The other side of the equation, which we haven't yet talked about, is that decisions on the shop floor are over-reliant on systems that require people. There are legacy manufacturing operation systems. You guys know them really well: ERP, MRP, MES. Systems are just heavily dependent on manual data input. They try to do everything themselves. They attempt to bundle all these features required to run and maintain operations within one system. And the simple truth is that no one system can do everything well enough. The fact they're expensive, difficult to deploy due to their custom nature, once they are implemented, if somehow successful, are expensive to modify for your changing business needs. The data becomes essentially a black box, and the user experience is, for lack of a better word, not good. And if you speak with any one of our customers or prospects, and I'd be interested in if any of you feel any differently here on this webinar, you'll hear that pretty much everyone hates their ERP and MES system. Because there are not enough skilled people, and because today's systems are over-reliant on these people, which they don't have, manufacturing operations in general are just highly inefficient. So this is evident in the data that we collect, which is that manufacturing equipment operated at a utilization rate of less than 28%. Now, it's not all bad. This represents a huge opportunity for improvement, and it's, for what it's worth, the reason why we started Machine Metrics in the first place. And I'm going to get through just a couple notes on who we are, and then I'll contextualize that within our presentation. But Machine Metrics, we easily collect and analyze data from this manufacturing equipment on the factory floor and transform that data from insights into actions for frontline workers and other factory floor systems to automate workflows around the operation of machines. The paradigm that we're really focused on here is driving people and systems with data. Now, the foundation of any factory digital transformation begins with the automated capture, transformation, and contextualization of machine data. And our Edge platform, which is how we collect data, provides a scalable solution for manufacturers, small or large, that can be self-installed to easily collect data from every asset that you have on the factory floor and enable actionable machine data insights in a matter of minutes. So you can easily deploy our platform in any factory using hardware, or you can install our software on a local PC. The process is similar to configuring your at-home IoT devices like your Nest. Now that data is streaming into the cloud, we transform that data into action via out-of-the-box use cases, such as the ones you see here that drive immediate value. Things like OEE, real-time OEE and production dashboards, flexible reporting, condition monitoring, configurable workflows that can alert frontline workers of pending issues or even trigger external systems such as maintenance or visual work instructions when these conditions occur. And the reality is once the machine is connected to machine metrics and these data items are streamed into our platform, this data can then be seamlessly integrated with your other factory floor systems to automate this machine data and insights across your other digital factory systems and empower them with real-time data. So our data is completely portable through APIs and to integrate your data into BI, custom workflows and reports, and other factory applications. All right, so enough about us. We're here to talk about machine monitoring. What exactly is it, or what do people think it is? Why is it so important to optimizing processes in the factory floor? Not to mention manufacturing operations as a whole. So on the right side, on the left side of this equation, we have essentially the current state of manufacturing, or what I like to call it, the problem. Most manufacturing on the factory floor is driven by people and systems. Yet, as I just discussed, a lack of skilled labor and these monolithic systems are stifling manufacturing, as you can see at the bottom on the factory floor, and thus decisions on the shop floor are just over-reliant on these people and systems. And this leads to the massive inefficiency that you see today, evident in our data. So what is the solution? Well, in a machine-driven strategy, this equation is actually flipped upside down. And the paradigm is corrected, where what you really need to be doing is driving your people and systems with the data from machines. The data from machines never lie and provides the insights necessary to drive action by people and by systems. So hence machine monitoring. If you can unlock the data from the machines and drive that data to people and to systems, you can create remarkable levels of value in the factory floor. And the reality is that machine monitoring is no longer a nice to have product, but a critical need to have for any factory looking to drive continuous improvement into the future. The honest answer to why now is really intricately linked to the low equipment utilization rate that I mentioned earlier in this presentation, and the reality that it can be fixed quickly. Solutions do exist that can automatically capture machine data and make it visible and utile to accurately track production, performance, and health of your equipment in real time. And it doesn't have to be very difficult. Now, I was at an event recently where after talking to a number of manufacturers, there was an undeniable sense of urgency in their voices. And the attendees expressed that technological solutions like machine metrics were no longer nice to have, but instead must have for success. And I think this urgency can be attributed, but not limited to two specific factors. Number one, after experiencing the supply chain failures like those that have been highly publicized, as many of you have probably read about in the automotive vertical, for example, leading OEMs are prioritizing initiatives to gain insight and visibility into supplier performance. And it's likely that new requirements for suppliers are indeed on the horizon, if not here already. And this could dramatically impact the relationships with contract manufacturers and potentially lead to a supply chain consolidation. I don't say that as to incite fear. I say that to be truthful and to incite action. Number two, manufacturers want to start innovating again. And Today, the greatest detractors from innovation are manual tasks that just require frontline workers and engineers to misallocate their time towards non-competencies. Now, new technologies like machine monitoring, for example, reduce the need for human intervention by automating these manual burdens and tasks like data collection, analytics, and removing them from daily workers' purview is enabling the prioritization back to being on innovation. So this moment represents a unique opportunity for all manufacturers to leverage machine monitoring and other technologies in the factory floor to drive continuous improvement and product innovation by leveraging data and integrating automation. Now, also easier said than done. The challenges in sourcing an effective machine monitoring solution are quite diverse. Most vendors in the space have approached the problem by offering a single component of a solution, such as maybe like hardware or software, or they provide general solutions that are not easily customized. And I'm just going to review some of these challenges that you see here quickly in successfully enabling machine monitoring solutions. So first of all, let's just start with the data variety. In modern discrete manufacturing plants, such as likely yours, there are a wide array of different equipment in use continuously and sometimes even intermittently. And several types of data can be captured even on each machine. Each machine has its own data collection standard, make, model, control type, and making it necessary to have a solution in place that can collect and standardize data from each of these different types of equipment. Not to mention that there are older equipment as well. The second issue comes with data volume. And because discrete manufacturing equipment is highly complex, numerous data points is often available for collection every millisecond. And machine monitoring systems have to be able to capture not only the relevant data needed to perform basic computations or even simple analytics, but it needs to be captured at significantly higher frequency to enable a number of other use cases, such as predictive analytics, which I'll talk about a bit later within this presentation. The third problem that we see is data speed. And many generic or even packaged systems today are only capable of capturing specific types of data at specific speeds. And because the amount of data required for collection can be just absolutely massive, the systems must perform these complex calculations in real time for the data to, or almost real time, for the data to be useful in any way, shape, or form. And many generic systems are just unable to capture the data at a speed that can result in non-latent decision making. So the fourth problem that we see is just disparate systems. So as we talked about before, traditional manufacturing often suffers from siloed data, and this results in this fragmented, disparate systems: ERP, MRP, MES, visual work instructions, maintenance systems. Now, while these systems were intended to make life easier on the production floor, or for scheduling or finance functions, the lack of interoperability and connectivity, integration between these systems means that data may be presented in different formats from system to system, and it may not be rationalized, creating these gaps and redundancies. The data, needs to be utilized together and unsiloed for it to create value in a holistic picture of what is really happening. And lastly, one of the biggest challenges that we've seen is just IT. The rise of these, scalable, flexible systems does have an impact on IT. Many of you have heard of this concept called IT and OT convergence. If you haven't, you can read about it. But this is a challenge at all company sizes. You've got IT departments. You're starting to embrace the internet, right? On the OT side, the operational technology, the machine and factory floor side of your business, and the requirements of storing and loading and keeping data secure that you're collecting is no small feat. And solutions for machine monitoring must reside in situated areas where that structure is better suited for this level of traffic, as well as the security that is just inherent in keeping you safe and your business safe. So, long story short, this is actually really hard to do. So don't try this at home. Don't try to rebuild this wheel from scratch. Attempting to rebuild a machine monitoring system is is a blatant misallocation of resources. It requires a huge cost to support these systems, and quite literally take you and your focus away from the core of your business, which is manufacturing and driving innovation around your products. I like to think of it similarly as, what if Machine Metrics decided we're going to start making products? Well, we're not manufacturers, so that doesn't make a lot of sense. So I know you might be thinking, well, how does this all work exactly? And the answer, of course, is magic. No, but seriously, allow me to walk you through the basics here, because I think a lot of people don't really understand how this all works, and it's quite complex when you look at it, but quite simple when you bring it all together. So at its core, machine monitoring, it has a quite literal definition, but the reality is much more nuanced than it sounds, because the answer to how machine monitoring works can actually have different answers depending on what exactly you want to monitor, when you want it to be monitored, and who and what will be doing the monitoring. But in general, most manufacturing machine monitoring systems follow a simple paradigm: connect to assets, centralize the data somewhere, and then monitor that data to drive insights. And in a modern platform setup, I'm leveraging the Machine Metrics architecture here, for example, so you can see what a modern platform setup looks like. The data from an asset is collected, oftentimes by a device in the field. For all intents and purposes, let's call that device that asset a machine tool, and it's collected through some device, maybe an IoT device or a gateway. It's relayed back to a central network server, or in layman's terms, pushed to a cloud or a local server, which I wouldn't recommend. Now, all that data is gathered and processed in this central location, usually in the cloud data center. Some companies use on-premise servers as a backup for that data. And all machines that need access to this data or use applications generally associated with it must first connect to this gateway. And since everything is centralized, the cloud is generally the best place to keep all that data secure and controlled, while still allowing for reliable remote access to this data from anywhere, from secure logins. And once that data essentially is pushed or processed, analyzed, if you will, in the cloud, which happens almost relatively instantaneously, but can be a matter of moments, if not seconds, it can be immediately accessed and then used through applications, use cases, if you will, that may be available through the data, this data platform, as you see in the center, in a number of different ways, whether it be through, to visualize that data in real time, to report on that data, to show diagnostic information on what's happening with your assets, to help improve your ability to make decisions based on this real-time data. Now, on the right-hand side, you can see that those forms manifest themselves in the format of visualizations or applications. Now, let's break out each of these components in a bit more detail, just so we're really clear about it. So, the foundation of any monitoring system is the collection and connection of data from assets, and this is the entry point of data into the monitoring platform infrastructure. So many machine monitoring systems, like Machine Metrics, for example, connect directly to the machine control systems using an Ethernet port and leverage these software adapters that are essentially programmed to run on hardware devices. Now, as many of you are aware, getting actionable data is really difficult, given that there are hundreds of different makes, models, control types, and connectivity protocols. So these adapters that are designed to connect to these modern control systems leverage protocols such as MT-Connect, OPC UA, and other data standards, as well as often various control systems that have their own proprietary adapters to connect to the manufacturing equipment control. And this is where the most important data lies, right? To capture, map out, collect, and standardize the data points that exist on that control. Internal sensors, machine statuses, modes, alarms, proprietary machine alarms, overrides, loads, feeds, speeds, temperature, rotary velocities, diagnostic PMC parameters. Now, for modern machines, using a sensor to collect data from an asset is akin to a doctor diagnosing cancer with his fingers on your pulse. Now, sure, it's a crude example, and sure, that doctor can tell you whether or not you're alive or not, but I'd prefer to have a blood test to know whether or not that I have a serious health problem. Now, some machines are essentially dumb and they have no built-in connectivity capabilities for us to connect to, or for any machine monitoring system for that matter. So sensors can and should be leveraged in those situations to connect to legacy equipment using digital and analog I/O modules. These are just two examples that you can see here. And you can connect those modules to temperature sensors, current sensors, and collect, the basic data that's required for, performance or even condition monitoring on your machines. Now, anyway, this connectivity software will often come pre-installed on these hardware devices, which are essentially small computers called gateways. Edge devices, gateways. There's a dozen different names for them, but you can also download that software that connects to systems. Even at least certain platforms like Machine Metrics allow this on a local PC. They then turn that PC into what they call a virtual machine, where no gateway or even hardware is required. This is a highly scalable solution, but most companies aren't able to actually do that, other than companies like Machine Metrics. Now, that data, once you are able to network a machine to that edge, software and hardware, whether that's a local PC or leveraging the gateway devices that we've just kind of talked about, that data is instantly and securely streamed into the platform using Ethernet, Wi-Fi, or cellular communication. Now, just a quick side note, despite the advent of 5G, the reality is that most factories don't have the ability to leverage that today. Ethernet and the networking of assets is hands down the best way to get data, into a platform so you can monitor your assets. If you have incredibly strong Wi-Fi, I'll give you a high five. Good for you, but it's usually not possible. So yeah, and yes, we absolutely, just to answer your question, Matt, yeah, we're definitely gonna go over the buyer guide for various specific software options momentarily. I'm just kind of getting through how this all works. Now, quickly, just to note here, one of the reasons why I said earlier that monitoring is a factor of time is because some platforms are able to not just connect and collect data from assets, but you also need to be able to process data in real time and drive automation to improve machine uptime, reduce maintenance costs of machines, and even identify when critical failures are going to happen. So in many situations, when reaction time of the cloud is in making decisions is too latent, or too slow. For example, when you're dealing with a CNC machine tool, an in-cycle stoppage to a machine tool must be a decision that's processed and actually decided, monitored, processed, and decided on that edge gateway, because these in-cycle stoppages often require very low, near zero lag time. So when a machine has to leverage an edge analytics or something specific, like predicting a tooling failure or a bad cut, that data takes too long to go back and forth for it to be monitored and then have a decision created. And that's where edge platforms actually sit in this whole ecosystem of value. Now, in the middle, you've got a data platform. This is where this receives the data from these devices in the field. And here the data is gathered, processed in central location. And the data platform essentially acts as a modern industrial data historian with ample information to fuel these use case specific applications and purpose built for manufacturing. And as you can see in this image here, once that machine is connected to a gateway and the data is pushed in the cloud, these data items are streamed to the cloud and available to be used in a number of different ways. For example, like as you can see in this image, many monitoring systems can integrate that data into other factory floor systems to automate that machine data digital thread across your other factory systems. And many systems like Machine Metrics provide open architectures, so you can integrate that data into your BI or create your own reports and workflows or integrations with factory floor systems and applications. However, many monitoring systems also provide applications that transform the data being monitored into insights. Some of those insights and the ways they manifest themselves are in the form of production monitoring. So, performance monitoring, dashboards and reports that provide, real-time transparency on the factory floor, a report of equipment utilization and making that visible through a monitoring of an asset can help justify capital equipment expenditures. OEE reporting that gathers availability and performance of data monitored by a machine monitoring solution, reduces the need for manual data entry at the factory floor and also allows for bottlenecks to be quickly identified. Now, another use case and another format of monitoring is condition monitoring. And this you could essentially define as a measure of specific equipment parameters, such as vibrations, temperatures, alarm states, taking note of any significant changes that could be indicative of a pending problem or failure. So continuously monitoring the condition of equipment and taking note of any irregularities that would normally shorten maybe an asset's lifespan or create a potential significant downtime is critical to creating value for manufacturers and one of the top use cases for machine monitoring systems. And tools like machine monitoring systems, as you can see here, for example, can be used to diagnose problems, and limits can be set based on those conditions and parameters, or even using alarms to alert operators or trigger external systems like CMMS or even visual work instructions when those situations occur. Now, to answer your question, of course, with dozens of machine monitoring platforms on the market, choosing a solution that checks all the right boxes can be quite challenging. And when budget and learning curve are also important factors, other considerations will help inform and define the right path to a solution. So to select a machine monitoring system, buyers should look for the right combination of features and functionality to fit their unique situation. Now, budget and learning curve are also important factors. There are other considerations that will help inform and define your path forward. Manufacturers should definitely be able to implement, maintain, and scale these solutions with ease while experiencing time to value in weeks, if not years, and so on and so forth. Now, we're going to explore each of these areas in detail. And so you can validate the top capabilities for any machine monitoring platform that you're going to be looking into. But I'll define each of these as I move forward and then kind of talk about them a little bit. But let's just start with device connectivity. So we define a critical parameter for any machine monitoring system. It should provide out-of-the-box support for a wide variety of industrial systems, devices, protocols, controllers, and not to mention not just for new machines, but for legacy machines as well. And there are 4 essential parts to device connectivity: machine adapters, data collection, data normalization, and data storage. Basic data collection from a select few industrial machines, it just doesn't meet the requirements for any manufacturer because very few manufacturers just have one machine or one type of machine. So the platform that chosen needs to be flexible in its ability to connect to a variety of equipment, makes, models, industrial protocols, new and old equipment. And while many OEMs may embed these connectivity solutions into their machines as a built-in feature, whatever solution that you work with should allow the capture of data via sensors as well, because it won't just be enough to have those modern equipment, but you're going to have to connect to machines that are essentially dumb and don't have that ability. So the platform that you choose should allow for the ability to not only connect to a wide range of assets, but also it needs to be able to standardize the data from these different systems into a common model. I know that this may feel like a confusing concept, or maybe not, but the reality is if I'm going to measure 5 different machines and each machine has a different data tag on its control for part, then it's going to be really difficult for me to measure how many parts each machine is making across all your different makes and models. So a system needs to be able to identify and have the experience in automated normalization of all those different data points, so you can have real-time automated collection and action for that data. So just to recap, the ideal monitoring system offers rapid data collection and connectivity to all modern legacy systems with just a few clicks. Now, you can ask yourself these questions when you're doing evaluation. Is a system capable of connecting to all of your assets? Does the system collection require additional data transformation after you've collected the data? How quickly and easily can that system be installed to connect and collect data? And can it do so with zero or highly or very little involvement from your resources? Now, the second parameter that we think is critical in assessing a machine monitoring platform is essentially edge management. When you have one or many edge gateways in use, it's critical to provide a single point of control to manage and aggregate data from a number of these devices, providing users with a complete picture of edge devices, applications, deployments, and updates, and also updates when your machine controls update as well, and those data tags and items changed. This can be quickly and easily updated across all of your devices. This happens often, that when a machine goes through a software update, literally the data tags that you're pulling off and monitoring on your machines change as well. And if a monitoring solution doesn't have a central ability to update those data tags for not just one, but all of your different types of equipment, then every time a machine software updates, your data is going to be confused. So it's critical that that central management provides one solution that can automatically retag those data items across all of your assets. So the questions that you want to ask yourself when you're evaluating a system, can you remotely diagnose connectivity issues on your gateway using the system? Do your data tags update when your machine software updates? Can you deploy algorithms that monitor and adapt machines on your edge? Can you manage where your data goes from your edge? The next piece of this is going to be talking about the flexibility and ease of use. Now, the right machine monitoring system will be easy and understandable to everybody who uses it. Now, not everyone on the shop floor is tech savvy, and the system must be accessed by operators and managers. Democratize that data, if you will. The user interfaces should be clear, intuitive. They shouldn't look like MS-DOS or AOL. It should allow for quick and simple data actionability. It should have visualizations that reflect the conditions of performance of the machine accurately. The same is true of the reports that are generated. The reports need to match the reality in what's actually happening on the factory floor, so your team can make informed decisions. The system. So the questions you should ask yourself around this is, does the system integrate with the other tools that you have? So are you free to build a technology stack that integrates with everything that you have and not locked into one vendor? Can this data be used across every department or different individual without significant expertise? Is it easy to configure or customize your system without paying a system integrator to do so? Not to put system integrators out of money, but manufacturers need to be able to reduce costs in this front. So for a system to be easily adaptable is critical. Now, on the scalability front, now I'm going to accelerate because we're coming up on our time. Manufacturers need scalable, flexible solutions that can connect to data from multiple machines, factories quickly. They need standard interfaces to do so. And they need each factory and frontline worker can leverage without requiring system integration, custom code development. So the questions you want to ask yourself on the scalability side are, how quickly can I roll this out to one machine, to all machines? How easy is it to train my users on these systems? How does the system work in multiple countries, different languages? These are things that you really need to consider if you have people in different countries or different languages, or within one factory for that matter. Now, many manufacturers and system integrators, consultants, vendors have attempted to rebuild the machine data collection and monitoring wheel from scratch. And these development efforts are on a whole almost exclusively unsuccessful. Once a mechanism for capturing and textualizing data from machines is built, it needs to be maintained. And not only is the cost of sustaining these solutions prohibitive, but the lost opportunity and value associated with just using allocating your resources to developing and sustaining something that already exists in a competency that cannot be achieved by almost any manufacturer results in a competitive disadvantage for manufacturers. So from the sustainability side, it's how many resources from your side would it take to manage a system? If none or very few, then you've got a big check mark, right? Does the system continue to improve and grow in its functionality? And is it the system always up and available when you need it? And if it's not, does it require you to do anything? If so, it's probably not something you should be using. Now, security is a critical evaluation criterion, and it should be at the forefront of any system that leverages the internet in today's world, especially when you're connecting an asset that uses programs which contain proprietary data and designs such as manufacturing equipment. So if security of an IoT environment is poorly implemented, it can have a drastic impact on cybersecurity of an entire organization. So you have to ask yourselves these questions. Is your system redundant in the event of an internet failure? So if you're using an on-site or on-prem manufacturing solution, and your on-prem server, which is managed by realistically, less adequate resources than, say, the billions of dollars worth of infrastructure put into cloud security, and it goes down, or your systems fail, or your servers break, where's that data? Is it gone? If so, that's going to be a problem, right? Has that system been validated or certified for security if you're managing your internal system? Does the platform separate your network of machines from the network that has access to the internet? I've seen many manufacturers connect machines directly to the local networks. Don't do that. So security is critical, and it needs to be at the center of every decision you make. Now, I could go on a diatribe here. Companies often pursue the path of on-premise software just because they think it's less costly, but it never is. The reality is that the cost of ownership is not fully considered when you're thinking about an on-premise versus like a SaaS solution. SaaS solutions don't require a company to own and maintain servers. For example, they eliminate the need to take on support, training, service, integration costs. So cloud platforms are more flexible. They're more modular. They allow buyers to start with what they need, allow functionality to grow, or new pathways or functionality as they become apparent. There's dozens and dozens of developers. Like we have 60 developers at Machine Metrics, for example, are working on our system all the time. Does any on-prem or on-site system have that many assets? Millions and millions of dollars a year put into working on it, improving its functionality, adding additional features? Of course not. Right? This cost of ownership just goes up and up and up the longer that you try to maintain an on-prem or a DIY machine monitoring solution. And the more those solutions just fall behind, so do you. So that's my end of my on-prem versus SaaS rant. Lastly, and I think I kind of just covered this, you really need a system that's going to be innovating and extensible in other systems. If your software can't integrate with your other systems like MRP, ERP, MES, BI, HR, work instructions, maintenance, then it's minimizing the impact that it can have on your organization and reducing the number of people within your company that can actually leverage that system. So number two, if the system is not innovating and driving new features, new abilities, new capabilities every day, every week, every year, then you're also falling behind companies that are using systems that are. So is your system require you to build all this yourself, or can you use out of the box use cases today to drive value? Can the system easily drive that data into your other systems? Not just put it on a dashboard. Right? Can this system update and improve over time? Now, of course, not all monitoring platforms are created equally, and of course, my monitoring capabilities matrix shows Machine Metrics as the perfect solution because it's my webinar. But it is undeniable that we've become the leader in the space, and there are certain key capabilities that help manufacturers create successful monitoring use cases. To select monitoring systems, buyers need to look for the right combination of features and functionality that fit you. And using this checklist, which we'll provide in the PDF of our deck that you can have after the presentation, you can compare and validate the top capabilities of any monitoring platform and we certainly hope that it is helpful to you. Now, before I get into questions, I have a brief epilogue that I'd like to share with you, which is that over the course of the pandemic, manufacturers have, of course, navigated a volatile market, leading most to realize, like I said previously, that just adopting effective automation and data-driven strategies is not just a nice to have, but is a requirement. And those who don't make this evolution today will quickly fall behind the ones that are. That said, and despite the undeniable potential of using solutions like this for operational improvement and competitive advancement, there is still this ever-present sentiment of self-doubt for many manufacturers about using data and using systems like this. So I did my best to kind of review those 4 top, doubts here, rebuking them as quickly as I can. So the first doubt that I hear is we don't have the ability to do this right now. Now, I want to be clear, this is not true. Most manufacturers assume, thanks to like the trauma induced from them from ERP and MES implementations, that this is going to be a massive endeavor. But the reality is that there's an ecosystem of modern manufacturing data software solutions like machine metrics, for example, that are relatively plug and play and don't really require significant resources or custom development on your team before creating massive value. So the answer is you do have the resources or the ability to do this right now. Number 2, we don't have enough people to dedicate to this project. Now, I hear you. There is an undeniable labor shortage across this manufacturing. We talked about it earlier, and it's true that ERP and MES systems are heavily dependent on these manual data inputs, as well as most other machine monitoring solutions. But fortunately, software solutions like machine metrics, the reason why we're so innovative is we solve this problem by automating so many of the tasks associated with the value created through these solutions that are historically manual or time consuming. That alleviates the responsibilities that your workforce is inundated with doing today, versus, and driving decisions to your people, not the other way around. So we can actually free up more of your people's time using solutions like this than the other way around. Now, third, we have other projects that we need to finish. Now, manufacturers want to pursue automation. They want to put off machine monitoring due to this conflicting priority, like purchasing new production equipment or outdated, business systems. But the reality is there's just no time to waste here. As I said earlier, OEMs are going to start asking you if you have data on your manufacturing, and they're going to require it to be automated capture. So if your machines aren't being monitored and your production data is not readily available, it's going to be a problem when those companies come knocking. So furthermore, if you use machine data collection and monitoring in parallel with your other new technology, it's a great way to maximize, even empower the impact of your overall value. Imagine, today putting in a maintenance system that's based on some arbitrary calendar to do your maintenance of your assets. The reality is if when the machines should be driving your maintenance, and when you use something like machine metrics, for example, to collect data from those assets, you can drive your maintenance system with machine metrics and not just, by, when a machine breaks down or some arbitrary calendar time. So the last one, and then we'll move on, is we're way behind everybody else already. And this self-deprecating notion is just not true. Everyone seems to think they're behind everybody else, but most manufacturers are just starting their digital transformations. Sure, some have accelerated faster than others, but in reality, every day wasted with this thought that we're behind someone else is another day where you're actually falling further behind that person, but actually getting ahead of somebody who's behind you. Thus, there is no time to waste. It doesn't matter if you're behind or ahead. You need to keep moving forward today. If you want to start innovating again, machine monitoring is one of the fastest ways to do so. I hope that this webinar was useful for any of you who are interested, and provide some criterion for you to evaluate what solutions work for you. And now we're going to move on to answering some questions because I know that there's a bunch of them out there already. So let's see.
Great. Thanks, Graham, for that presentation. We have a few minutes left. So So I just want to hit on some of the live questions asked during the event. First off, Tim asked, do you require that data be sent to the machine metrics cloud, or can data be kept locally? If so, will it have the same value from an analysis and reporting point of view?
Great question. The answer is that data from machine metrics is always sent to the machine metrics cloud platform, but it is also locally stored for short periods of time on the edge platform. The real thing is that when data is pushed into the cloud, which is what I believe categorically the most secure way and to collect and manage data, it provides significantly more use cases. Number one, because it's available from anywhere, anytime. So, in a constantly more remote world, the ability to aggregate significant amounts of data using a significantly lower cost infrastructure and data storage, such as the cloud, allows you to have all of your data in one place without having to manage, server racks the size of, an airplane hangar. So that's kind of number one. Number two, once that data is in the cloud, it is definitively more actionable because it's made more available to more users, right? So because not everybody's able to work in the factory today, you're able to leverage that aggregate data and make it instantly visible and usable for a number of different users within the factory, not just frontline workers, but engineers, operations, literally anybody and everybody, without having to spend your time managing the data storage, which is just something that I believe no manufacturer should actually have to do. I hope that answered that question, Tim. If not, feel free to add a follow-up there.
All right, sounds good. I think we're going to move on for the time being now. Tim, feel free to drop in a follow-up in the chat. Graham, next question. Paul asked, how do I know if machine metrics can connect with my machine?
Great question. I'm sorry, Laura, would you, forgive me. Could you just repeat the question one more time? So sorry.
Of course. How do I know if machine metrics can connect to my machine?
Great question. I think one of the things that makes our platform unique is machine metrics has yet to encounter a machine that we can not connect to. I think the real question becomes what type of data can be collected. So most modern equipment, if there is an Ethernet port and it supports OPC UA, FANUC Focus, MT Connect, has a Mitsubishi Citizen, Heidenhain, Haas control. If it supports Ethernet IP, Modbus TCP, MQTT, we can get data from that machine. So there's a shorter list of machines that we cannot collect data from than machines that we can. We've had companies that have integrated machine metrics onto manual welders, chillers, even AC units. I know somebody that integrated machine metrics on a record player, and I still get notifications when that record is running too fast or too slow at that facility. It's pretty cool for what it's worth. But if you have any questions more around that, you can reach out to us and we can assess the makes and models of your machine just to determine that, the method with which we can integrate and what data specifically we'd be able to get from those assets.
Right. Okay. Thanks, Graham. As always, feel free to chat us with follow-up questions. I think that's all we have time for now. I'm sorry.
I think we have a couple, Laura. I think we got a couple more here. Forgive me. Do you mind if I jump in real quick?
Yeah, go for it.
I think we've got 5 minutes, and in the Q&A, I've got a couple of good ones. So, first of all, Tom, you asked me if I can show you an operator interface. You can definitely check them out on our website. I'd hate to have to share the screen again. The answer to your question is operators can absolutely indicate multiple reasons for why machines are down. You can configure that. It's eminently customizable and configurable to you and whatever reason that you want. So I hope that answered your question, Tom. Joe, great question. how do you balance security concerns against digital transformation with storage in the cloud? So the reality is you don't want to set up your own cloud secured servers. And this is like, I think what it all comes down to is that, when you're able to leverage systems like machine metrics, you're essentially getting the power of companies like Amazon Web Services. You might know them more as AWS more familiarly. And AWS spends billions of dollars a year on infrastructure. That data in those data centers are not just expertly secure, but are literally guarded by armed guards in the center of the desert. It's likely, Joe, that you're correct, and the stat that you indicated that cloud servers are 60 or 70% set up incorrectly, and that's likely because manufacturers are trying to do it themselves, and that's a mistake, like we discussed earlier. Leveraging multi-tenant servers like AWS or Azure or Google, even for that matter, we can reduce that insecure setup by as much as those servers are set up insecurely to support manufacturing operations. I think this question is really representative, though, of I think there's like an inherent, and you guys can correct me if I'm wrong, but there's because manufacturers make things, there's this inherent belief that they should make many things, or we should make all things. The reality is that whether it's software, whether it's cloud servers, local servers, these are bound to be bad misallocations of resources and time, and are inherent in the failure rate that you mentioned in your comment. So, Joe, I hope that answered that question. If it doesn't, feel free to reach out to me directly. I'd be happy to answer any other questions that you have around it. We've got about 3 minutes. So if we do have any other questions, I'd be happy to answer them while I'm here. Otherwise, feel free to send me email. My email is graham@machinemetrics.com. You're also welcome to reach out to us at info@machinemetrics.com, or you can go to our book a demo page if you'd like to book a demo and see how the platform works. So thank you all for the time. Laura, I'll give it back to you.
I have a quick question that I can throw at you. If you can talk fast.
I'm pretty good.
Someone asked, besides CNC machines, does machine metrics, machine monitoring work with any other type of industry?
That's a good question. One of the reasons why we're so successful in this vertical is because we aren't focused on like connecting to airplanes or jet planes or belt baggage claims or tractors in the field. We're really focused on discrete manufacturing equipment, and that's really where our focus is, and that's where we spend the significant amount of our time. That's what allows our system to be so good at what we do. So turning, milling, stamping, fabrication, injection molding, cold heading, lasers, axes, grinders, welders, robots, cobots, you name it. That's where we live. That's our vertical, and that's the type of VATs we can connect to. Laura, I also see there's a quick one that just came in from Peter. How long does setup time take? And the answer to that question is highly dependent. Some manufacturers get set up in machine metrics in an afternoon. Others it takes a few days, sometimes a few weeks. I think it really depends on the complexity of your equipment and what you have set up. I would say that I feel unequivocally confident saying that the setup time in machine metrics is faster than any other system that exists today, and it's one of our advantages for using for other systems. So we'd be happy to show you exactly how long that takes if you want to reach out to us directly, and we'd be happy to quote you that type of time. So I know we're at the top of the hour, so Laura, I'll kind of kick it back to you for our sign off.
Right. Well, as always, thank you everyone for joining. If you really liked this presentation, we run a lot of similar ones. I would recommend staying in touch with us, connect with us on LinkedIn and Twitter, join our emailing list. We always promote them, these events. So you can keep an eye out on your calendar and join the ones that you can. Otherwise, thank you for your attendance today, and reach out with any other extra questions. Thank you all.